Hello everyone, this video is another continuation of multiplying and factoring with quadratic expressions. So we've talked about the one rule that you can use to factor any quadratic expression, and in this video I'd like to apply it to some binomials. Okay, so we have 3x squared minus 75. So step one, figure out if the GCF is a 1. And it's not in this case, I can factor out a 3 right away. Alright, well what's left? X squared minus 25. Alright, see the part 1 video if you need help with factoring out the GCF. Alright, and then I want to focus on what's left and use the one rule for factoring. A times C. Well, notice here we actually have two terms, so let's be extra careful. This is actually x squared plus 0x minus 25. So A and C would be 1 and negative 25. Right, multiplied would be A times C would be negative 25. And then B is actually a 0. So now I'm looking for two numbers that multiply to be negative 25 and add to be 0. All right, so 1 and 25. And the only other thing that goes into 25 is 5. 5 times 5. Now it's a negative 25, so one of these has to be a negative, and it's not going to be this first option. Okay, you'll get 24 or negative 24. But this next one, if you make one of the 5's a negative, then when you add negative 5 and 5, that does equal 0. So that's the combination we want. All right, now you've got two options here. We said previously if the A here is a 1, then you can just jump to your final answer, and it's going to be x and x, and then these two numbers are going to be the rest of those factors, so minus 5 and plus 5. You may have also learned a rule for a difference of squares, and we'll talk a little bit more about that later, but that's what we're doing here. Alright, so let's do the long way. I just want to show you and confirm that shortcut does work. So I'm going to rewrite this. I'm ignoring the 3 for now until the end, but I'll rewrite this as x squared okay, and then in the middle, instead of 0x, I've got negative 5x plus 5x, and then minus 25. Okay, factoring the greatest common factor out of the first two terms, that's x, and what's left is x minus 5. And out of the second two terms is a positive 5, and what's left is x minus 5. Okay. Then in these two terms, both of them have a factor of x minus 5, so I can use the distributive property and pull that out, and then see what's left. And what's left is an x plus 5. Alright, and sure enough, that's what we had using the shortcut. So the final answer here, the only thing that you need to make sure you do is also copy down the 3. So this was 3 times the factored version of x squared minus 25. So 3 times x minus 5 times x plus 5. Okay, final answer. Alright, here's another one. 4x squared minus 9. The GCF of 4 and 9 is a 1, so we're just going to use these numbers as they are. Notice that this is, again, a missing middle term, so this is plus 0x minus 9. Alright, multiplying A times C, 4 times negative 9 is negative 36, and we need numbers that add up to be 0. Okay, so you can go through and write all of your list of factors. 1 times 36, 2 times 18, 3 times 12, 4 times 9, 6 times 6, and then we stop. We're in the middle there. Okay, we've got a complete list of factors. Alright, the combination, make one of those negative and see which one adds up to be 0. It's going to be this one, 6 and negative 6. Okay, so this one did not have an A, that was 1, so we do need to do the longer method. So I'll rewrite this 4x squared. Instead of 0x, I'm going to make this plus 6x minus 6x, and then minus 9. And then I pair these up and factor out the GCF from each pair of terms. Okay, out of the first two, from 4 and 6, I can take a 2, and from x squared and x, both of those have x as a factor. What's left? That would be a 2x plus 3. And then the second two, I'm going to take out a negative 1, as well as the GCF of 6 and 9, which is 3. And then what's left? 2x, and this is now a plus 3 because I pulled out the negative. Okay, then I have a matching 2x plus 3 that gets factored out. And what's left? We've got a 2x and a minus 3. Okay, so that's the final answer. Now, if you look at these last two, you may have noticed something that they had in common. And let me write the other one down so you can see it. And we've got the final answer there. Okay, the other one was 3x squared minus 75, and once I took the GCF out, it was x squared minus 25. All right, and the answer was x plus 5, x minus 5. All right, so notice the factored version ends up just being the same numbers, but 1 plus and 1 minus. And so this is another little shortcut or pattern that you may have learned before. And this happens anytime we have a difference of two squares. A difference of two squares. All right, well, what do we mean by a square? Things that are perfect squares would be like 4 because it's 2 times 2, 9 because it's 3 times 3, 25 because it's 5 times 5, etc. So when I look at 4x squared, that's a square, that's 2x times 2x. And 9 is a square, that's 3 times 3. And it's a difference because there's a minus sign in the middle. So shortcut, when you see a pattern like this, it's always just going to factor as the square roots of those two things, the 2x, the 3, and then you're going to have 1 plus and 1 minus, and those are needed so that the middle terms will cancel. That's why you're not seeing a b. That's why you don't see a middle term with the 0x. All right, one more example would be, we can make up anything here that's a square. All right, if we had like 25x squared minus 64, okay, so assuming that the GCF is factored out, which it is, 25 and 64 don't share common factors, then the answer is just going to be the square roots. So 25x squared becomes 5x and 5x, 64 is 8 and 8, and then 1 plus, 1 minus. Okay, so if you like that pattern, use it. If not, then just continue using the same rule that we've been using all along to factor. All right, in summary, is it fully factored? To check, make sure that the GCF of all terms is 1. That's the first step that you always do. If you don't do that, then you're going to end up with an answer that's not fully factored. And then secondly, use that single factoring rule to confirm that nothing else can be done. Right? Now, two other things now we can look for. If you have a linear factor with the GCF equal to 1, so something like x plus 3 and 4x minus 7, right? I don't need to worry about can these be factored anymore because these are linear. The exponents on the x's are 1s. So as long as I've worked with that GCF and make sure that that's a 1, then I can know for sure that this is finished. There's also a possibility you can end up with a quadratic factor that's not a difference of squares. And if that's the case, then we can't factor that. So if I had something like x squared plus 8, that actually can't be factored, right? It's not a difference of squares. 8 is not a perfect square. So the last thing I want to do, let's confirm that this is not factorable by trying that method. Okay, so a times c, 1 times 8 is 8, b is a 0, and notice what happens now when you go to look for two things that multiply to be 8 that add to 0. Alright, I can do 1 and 8, and 2 and 4 are the only options. Alright, and I can leave these both positive, or I can make them both negative. So when I add them, I'll end up with answers that are either 9 or negative 9. And here I end up with 8 or negative 8. But none of those can add up to equal 0. So if you ever have a situation where you can't put anything in these two spots when you're using the factoring rule, then the expression is not factorable. And the reason that it's not is because its factors are either not integers, maybe they're square roots or something like that. Maybe they're not even real answers. So in this unit, we're just dealing with things that are factorable into products of expressions that have integers involved, and we're not really worrying about things with square roots right now. Alright, here's one more example, x squared plus 5x plus 5. So a times c is 1 times 5. B is also a 5. So I'm looking for things that multiply to be 5. And the only integer options are 1 and 5. And I could also do negative 1 and negative 5. But that's going to give me either 6 or negative 6. There's no way for those to add up to be a 5. Alright, so I can't find anything for here. And if your directions say factor this, then you just leave the problem as the answer. And that's all you can really do. Okay, so I hope that was helpful. You should now know how to multiply quadratic expressions together. You should know how to factor them. And the next thing that we will do is work on solving quadratic equations using those the factoring rules that you've learned.